list some properties of nonmetals then, okay? These are all on the right side of the table. If they're the opposite of metals, how could we describe nonmetals? Jacob? And not what? Not usually ductile malleable, and they're also not shiny. Very good. They are poor conductors, meaning they're insulators. And they're also not shiny like metal. There are also lots of examples. I just put 2. Neon, oxygen. Most elements on the far right side of the table would be considered nonmetals. They could go there. Brooklyn, question? You have a question? Or you want to do the next one? Okay. No. Nope. Okay, number 15. What are the groups on the periodic table? If someone said, what are groups on the table? You would say they are the... Matthew?
The noble gases.
Well, that is one type of group.
Wait, do I just say the type of group?
No, what if I were to find, okay, what are the groups as opposed to the period?
So, like, how many groups there are?
No, meaning, are the groups the ones that go up and down or left and right?
Oh, the groups are the ones that go up and down.
Good. The groups are the vertical columns on the table. They share similar properties, and we have groups numbers 1 through 18. If elements are in the same group, they usually have similar properties. All the elements in group 1, they are alkali metals. They're all highly reactive. All the elements in group 18, noble gases. They're not reactive. Okay, the groups are vertical. They go up and down. Number 16, then, what are the rows called? Imee? Period. And there are 7 of those. Matthew?
Are you gonna have to take down the periodic table thing?
Micah just asked me if it's going to be covered up, and I said no. So no, I won't. You'll see why at the end. I'll explain. 17. A small group of elements on the table are known as metalloids. Why? Why do we call them metalloids instead of metals or nonmetals? What do you think, Siksha? Why do we call them metalloids instead of metals or nonmetals? Are they like metals? The metalloids are that middle group, kind of where the stair stepper is. Are they like metals? Are they like nonmetals? They're kind of a little bit of both. Okay? That's why we call them metalloids. They have properties of both metals and nonmetals. They're kind of the middle ground. They have properties of both metals and nonmetals. Okay? Number 18. What is the atomic number? Yes, I know that it's the whole number in the box on the table, but what does that mean? Manny? And the nucleus. Very good. It is the number of protons in the nucleus of an atom. The number of protons in the nucleus of an atom. Okay, what is the atomic mass? Jacob? Basically, yes. It's the average mass of the different isotopes of that element. Okay? We know now that isotopes are different kinds of that same element that have more or less neutrons in the nucleus. Okay? Now, some elements can exist as different isotopes. Okay? Aluminum may have 5 or 6 different types of isotopes that exist, but if that's the case, to find the atomic mass, we take the average of all those isotopes. Give me right, please, Ellie. There you go. Thank you. Okay. All right. Next one. Going to the next page. Number 20. How are the symbols of the elements made up? How do we get the symbols for the elements? What do you think, Edgar? Okay, so for example, the symbol for oxygen is capital O. Where does that come from? Why is it capital O and not capital M? Because the name starts with an O in English, right? But does it always come from the English name? Sometimes it comes from the you remember where we get the symbol for gold? Symbol for gold is AU, right? Capital A, lowercase u, which comes from the what name? What language? Connor, help him out. The Latin name. Good. The symbol comes from either the English or the Latin name. Gold is one that comes from Latin, AU. Silver is one that comes from Latin, AG. Kind of all over the place. Chloe, you with me? Okay, the next three is what is a molecule, what is a diatomic molecule, and what is a compound. We're going to write short versions of these definitions that kind of help distinguish them from each other. Okay, so for molecule, 2 or more atoms. If you have something made of 2 or more atoms, boom, you have a molecule. Jacob, you with me? Okay. All right, if that's our definition for molecule, what is a diatomic molecule? Think about that prefix di. Wyatt? Very good. Only 2 atoms. Okay? 2 and only 2. So, let's look at these here. Is this diatomic?
Yes.
Yes. 2 atoms and only 2 atoms. Is this diatomic?
No.
No, there's 3. Is this diatomic? No, there's 3. 1, 2, 3. Is this diatomic? Yes. Okay, good. Now, if that's a diatomic molecule, then what is a compound? Oscar? Not more than 2. More than 1 element. Yes, you're right. 2 or more different atoms, which is another way of saying 2 or more different elements. Different types of atoms would automatically be different elements. Okay, the next one. Question, Ian? Yes. Brian? Oh. Yes, give me 1 second. Brian?
So our molecule is hydrogen and oxygen, right?
Yes. All right, Ian. 24 says give an example of how compounds have different properties in the elements that make them up. So I'm looking for something that is made of elements that are like two ingredients that are totally different by themselves, but come together to make something totally different. Just explain it.
Okay, so when chloride and chlorine and
Sodium.
when they combine sodium chloride, which is
Good. So sodium by itself is what? It's not poisonous, but
highly reactive to
good. It's an explosive metal. Chlorine by itself is a good. And when they come together, they make table salts. Okay? But Brian, the example you just asked me about, that's another example. Water. Hydrogen is a gas. Oxygen is a gas. But when they come together at the right amounts, it makes a liquid. Okay?
So if the world was like the air and the world was helium,
Mhm.
helium could hydrogen be like balloons?
Maybe, yeah. Matthew? I don't know, but you should start writing this stuff. Riley?
I can't really think of balloons.
Yes. Aiden?
The best way to think of a ship is a bunch of sodium in the base of the ship and fill the whole up.
Maybe.
But then you would explode. Or just shoot it because you're in there.
So the water reacts with the sodium. Okay, 25. What is a chemical bond? Micah, did you have a question? Okay. Chlorine, yes. 25. What is a chemical bond? Okay. A chemical bond involves. Oh, here's my question. Is a chemical bond an actual thing? If you look at a molecule, is this stick actually there? No. So what's holding the atoms together? Wyatt? Kind of like a magnetic force, but it is a force. Okay? So it is a force which holds atoms together in molecules. Now, there are two types of chemical bonds that we went over. Ionic and covalent. Those are going to be next. We're going to kind of just define how those are different. Yes.
Basically, the entire study guide is made up of short answers.
For the most part. Okay, so the two types of chemical bonds, ionic and covalent. Okay? What is an ionic bond? Or really, what happens with the electrons in an ionic bond? Riley? Not an ionic. Sharing is covalent.
Oh,
They give away or donate their electrons. Good. An ionic bond is a chemical bond where electrons are given away or donated. Your example, you do need to have this example, is sodium chloride. Capital N, lowercase a, capital C, lowercase l. It's a type of bond where electrons are given away or donated. Okay? We'll have to wait and see. Okay. All right, then what is a covalent bond? Sophie? I know you were going to say that. What's a covalent bond? Think about covalent, like a co-partnership. The electrons are what? They're what? Louder? Jacob. Are they given away? No. Instead, they are combined? No, not combined. Matthew?
Chemical bond where electrons are shared.
Shared. That's what you're looking for, Sophie. Shared. Both atoms are using them, therefore the electrons are shared. Okay? And then our example is water, H2O. Chemical bond where electrons are shared. For example, H2O. Yes.
So for water molecule, you say H2O. For a table salt molecule, would you say NaCl?
Yeah, I guess so. Although, really, this is called sodium chloride. I don't think this has a name, actually, except for just H2O. That's a good question, actually. All right, 26. I know the numbering's all messed up, but it should be 28. The atomic number for silicon is 14. So, how many protons, how many neutrons, and how many electrons are in one atom of that element? Oscar? 14, 14, 14. 14 protons, 14 neutrons, and 14 electrons. You can put it like that. Now, on 27, it says, draw a beryllium ion, an atom of a beryllium ion with a negative charge. Go ahead and do that on your own, and then I'll draw the answer on the board. Beryllium is capital B, lowercase e. It's in the top left of the chart. Okay? You're drawing a beryllium ion with a negative charge. Edgar? All right. So, for our beryllium atom, how many protons do we start with? We always start with protons, right? How many? Matthew?
4 protons.
4. So 1, 2, 3, 4. Plus, 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 plus. How many neutrons, Matthew?
4 neutrons.
4 neutrons. 1, 2, 3, 4. I'm leaving them blank because neutrons are neutral. And then Matthew, how many electrons?
So my beryllium ion is very happy with 10 electrons.
Well, that is a very happy beryllium ion. Okay? So, because it's an ion, my number of electrons has to be different than 4. Okay? But because it says a beryllium ion with a negative charge, I need to have more negatives than positives. So I got to have more than 4. So 2 on the first shell. And then any more than 2 on the next shell. So Matthew put 8 on the second shell. Works for me. Okay? All right. On the next page, let me explain it to you, and then I'm going to let you work on it for a little bit on your own. The periodic table hunt. There is a part on the test that will look very similar to this. Okay? However, you will be able to use a periodic table, just not the one in your notes. I will give you another copy just like the one I gave you in your notes, but it won't have any of your writing or coloring on it. Okay? But you will use that table to fill this out. Okay? Now, let me go ahead and tell you that the valence electrons, these ones right here, are kind of difficult to fill out for some of the bigger elements like silver, radon, germanium, things like that. Okay? I don't think I actually have those on the test, but I will go over with you how to do those. Okay? So, for the rest of class, for the next 10 minutes or so, I want you to work on this with your chart. Tomorrow, we'll start by going over the answers for this and then completing the essay on the study guide. Okay? Jacob? The periodic tables, I'll pass the ones we're going to use out for the test, I'll pass them out with the test. Right now, you can use yours. Brooklyn? Yes. Let me get with you in a second.